G'day everyone, welcome to Lubrication Experts. Today, got a really important interview. So we're going to be talking about lubrication and its relation to sustainability in general. So this one is obviously very important for everyone who either cares about the planet or simply cares about their bottom line, right? This is actually a little bit of a riff on a couple of articles that were published in Precision Lubrication magazine. So some of you may know I'm involved in that. There's a really, really strong editorial board as well. And one of those people is Greg Livingstone from Fluitec. So Greg has written a couple of fantastic articles, and there's another one about to be published on the theme of sustainable lubrication. And so we're going to cover some of the same ground, but also broaden it a little bit as well for the purposes of this interview. Now, Greg is a returning guest, so back by popular demand. And so Greg, thanks so much for joining us.
Ray, thank you again for the invitation. I just want to point out that I don't have a lot of time in my daily schedule to watch YouTube videos, and I am so grateful that you have made this podcast, which I listen to religiously and love. So thank you so much for doing that, and appreciate being back here.
Yeah, awesome. I mean, funnily enough, there's a lot of people share that opinion. So I think there's probably, I think, double to triple the number of people that actually listen to the podcast versus watch it, which makes a lot of sense, right? Because, I think it sort of lends itself more to an audio format. The video format just sort of takes your attention away from what you're actually concentrating on. So this longer format, I think, lends itself a little bit more to listening to it on a run or in the car on the way to work or something like that. Now, just to jump straight into it, and if we can kind of contextualize the importance of lubrication to sustainability, right? So by some estimates, I've seen that industrial energy consumption represents in that ballpark of about a third of total energy consumption, right? And you've got transportation is roughly another third. There are some estimates that indicate like one quarter, I think, is the number I've seen. There was a publication by Holmberg and Erdemir in 2017 that indicated there was about a quarter of all energy consumption is lost due to friction. Now, in your experience, is industry actually aware of how big those numbers are? And if not, what's some of the kind of work that we can do as an industry to promote our field in this way and more clearly link it to sustainability?
Great question. So first, before I jump into industry, I think societally there's not a lot of awareness on tribology. So just when people have their knee, they have to get an artificial knee or something. They don't think about the tribology that goes into lubricating the knee. If there's a major earthquake, no one thinks about the tribology of tectonic plates interacting. Societally, I think we have a long ways to go to recognize the value and importance of tribology. But moving into our industry, where everyone knows what tribology is, there's still a pretty significant lack of knowledge on the critical role that lubrication plays in reducing friction and how that is then correlated to energy consumption. So I think the focus on lubricants and industrial lubricants in the space that I am in is really on reliability engineering and how lubricants can be used to maintain or enhance the performance of equipment. Um, Ironically, these are the same objectives as trying to make your lubricant more sustainable. So, optimizing the performance of a lubricant can be directly correlated to its energy usage and carbon footprint. So, how can we better communicate this to the industry? Well, I think one way is just by tying this link between sustainability and responsible lubricant management, setting up a good lubricant program. All of this lends itself well to sustainability. And I think as companies become more committed to decarbonization, all aspects of their operations will be scrutinized and getting down to eventually down to lubrication and how lubricants can actually improve the energy efficiency of their operation.
Yeah, that's really interesting. I mean, maybe just as a bit of a sidebar, if anyone wants some material that's really just interesting about tribology, the book Sticky by Laurie Winkless, who was actually on episode 16 of this podcast, is a fantastic introduction to all the ways that tribology affects our lives, through paints, sealers, boats, knee reconstructions, even like the feet on a gecko. So that was a really great way of popularizing tribology for anyone that wants kind of like a general introduction to it.
I bought that book and read it after I listened to your podcast. So very good suggestion. That was an excellent podcast.
Yeah, awesome. Now, obviously, trying to focus a little bit more on industry, and you talked a little bit about having to scrutinize every part of industrial operations, and lubricants are just going to become one of those. Now, that is kind of a bit of a window maybe into where we're headed. Right now, when we do things like carbon assessments of a lubrication program or a new product that we're trying to introduce, do you find at the moment that that is a compelling kind of piece of evidence for end users? Like when they see a carbon assessment, is that something that they jump on?
I think the answer to that is really divided by industry segment and geography. So, for example, I think in Europe we see it's much more common for our customers to ask about life cycle assessment of our products or lubricants. I think there's a much higher interest level currently in understanding carbon footprint and life cycle assessment. Um, and we also see in certain verticals as well, marine industry, for example, we see there's a very high interest in understanding carbon footprint and also energy efficiency. So those are a couple examples, but I do see a day where organizations essentially have two sets of accounting: financial accounting and carbon accounting. And so we already see many organizations are already doing this. And I think the widespread adoption of carbon accounting will compel eventually users to investigate, every aspect of their operation, eventually including lubricants. And one final thought on that is that I think maintenance organizations currently, if they're just reporting on the efficiency of their program, I think there's a big benefit in actually reporting on the same efforts are making if they can actually quantify how that is impacting their organization's carbon footprint. I think that increases the visibility of the maintenance organization and really only has upside.
Yeah, that's awesome. Um, One thing I'd maybe have a question about though is that historically, whenever I've tried to do one of those assessments, it's always been quite difficult to get hard data, right? So the energy efficiency of lubricants, or even the life cycle cost, like in terms of carbon cost of a lubricant, the numbers have always been a little bit nebulous. Um, so part of making a compelling case for making a change is often having like hard evidence. It's often hard to get direct measurements in a lot of these industrial machines of the effects of the lubricant as well as the total life cycle cost. So, are there any standardized ways that we can do some of those assessments?
Would say there's not today, but shortly there will be. I think what you're asking is it's a really good question because I think one of the challenges we see with, especially with energy efficiency or energy efficient lubricants, is that well they're more expensive and users aren't readily willing to invest in these unless they can measure some sort of gain. An energy efficient lubricant is typically made with more refined base stock, with viscosity index improvers. There's more complex chemistry. It can be twice as expensive, and but it can provide maybe 3 to 8% improvement in energy efficiency. So how can users more readily adopt this? So I think ASTM has developed a standard D7721 that helps directly compare one product to another and help measure its energy efficiency. So that's really good. It it really helps you set up an experiment to minimize test variables, but it's still fairly complex for most end users to be able to measure this. And what they would ideally like is just to see their energy bill go down each month. But there's so many variables involved in that; it's very hard to measure. So it doesn't actually mean that because you can't measure this directly with your monthly energy bill, that there's not a really significant improvement to moving towards more energy efficient lubricants. but we need a common methodology to measure this. And I think this is where maybe mathematical models may
Mm.
fit into this. Um, so there right now there's not really any kind of industry vetted mathematical models that really that you can plug in all the various different parameters of an equipment and be able to determine by having a more energy efficient lubricant or lowering the viscosity, the output will be an energy savings of X. However, I think we're moving in that direction. There's a lot of research going on in this space right now. Um, Texas A&M, their turbo machinery lab just came out with a mathematical model that looks at reducing or how lower viscosity lubricants will increase energy efficiency in gearboxes and in turbo machinery. So I think we're starting to see a lot more work, but ultimately, I think we're going to be somewhat reliant on some of these mathematical models that are then vetted to well controlled field systems to really measure some of these small savings that we can see with across the board and more energy efficient lubricants.
Yeah, that's interesting, and having some of those standardized methods, I think, will help a lot because, um, you know, like you were saying, setting up some of these experiments in the field can sometimes be pretty challenging and very technically involved, and in some
Yeah.
cases, I don't mean to dismiss anyone, but it's often beyond the reach of a lot of organizations to be able to set up something like that as well. So to be able to have some kind of standardized mathematical model, I think would really help. One thing I would say though is, I mean, you and I are both familiar with this, that there's sort of two aspects to our industry. There's the technical side and then there's the people side, right? And you can make
Yes.
a very convincing technical argument, but if the people are not receptive to it, then it's going to fall on deaf ears. So you talked briefly about the types of industries that might be a little bit more receptive to this kind of work. Are there also particular positions within organizations that are more receptive to this? So I don't know if in your experience, for example, that uh, maybe procurement tends to have KPIs that are more focused on sustainability, or is there an emerging job class which is like a sustainability officer? I don't know. You tend to deal with the bigger end of town than I do. So what's your experience been?
Well, it's interesting. I so we have seen this emergence of this new role in chief sustainability officers, and many companies have these roles. And you would think that they would have a really high interest in the carbon footprint of lubricants, but at least so far in my experience, the reality is that lubricants still play a fairly small role in the overall carbon footprint of an organization, and they're really focused on the big low hanging fruit that they can have a significant impact on lowering their carbon footprint. So in our experience, it's actually really the reliability engineer that actually works for a company who is really striving and on a path to decarbonization, that has the most interest, at least in our experience, in the carbon footprint of lubricants.
Hmm, interesting. Interesting. Now, when we make these assessments, I think primarily at the moment we've been talking about energy efficiency. You know, if we go to an alternative, so maybe it's a synthetic lubricant, maybe it's a PAG, there are usually some measurable benefits, or even if we drop a viscosity grade, there's some measurable energy efficiency benefits. But in the articles that you've published in Precision Lubrication, you talk a lot about this idea of a complete carbon assessment of the life cycle of the lubricant. And there are two particular terms that you use there, one being cradle to gate assessments, and the other one being cradle to grave. So maybe if we could step back and first just talk about general terms about how we do life cycle assessments, and then what is the difference between those two different types of assessments?
Excellent. Well, life cycle assessment is really the gold standard to fully measure the environmental impact of a product. So, cradle to gate refers to the total environmental impact a product has from the moment of its inception to its manufacturing and to the moment before it leaves to the customer site. to the gate of shipping per se. Or so, if from a lubricant perspective, this would encompass extraction of the crude oil, refining, production, blending, packaging, and so that would be a total carbon footprint of so cradle to gate of that lubricant. Cradle to grave takes into account two more things. It takes into account the actual use of the product and what happens to the product at the end of its life. The ironic thing is that this actually has the cradle to gate is a smaller impact than the actual cradle to grave. The what people do at the very end of the life of the oil, for example, if they incinerate the oil at the end of its life, that actually has a larger carbon footprint than all of the other previous steps. And the challenge in this is that most LCAs that are done that are made public are typically cradle to gate. So it's actually hard to get full cradle to grave analysis, life cycle assessment of lubricants. So we're starting to see that more and more. But the at the end of its life, it really depends on if the lubricant is re-refined or if it's incinerated, and those are fairly big differences in carbon footprint. But this is one of the reasons that my company Fluitec is so focused on maximizing the life of in-service lubricants because that actually has the biggest impact on reducing the carbon footprint of a lubricant.
That is wild. I did not know that about incineration, but that's really interesting. And so, if I could maybe take some other terms that people might have commonly heard of, is that cradle to gate versus cradle to grave almost like, let's say, from the perspective of the lubricant companies, that's sort of the difference between scope 2 and scope 3 emissions? Because scope 3 is taking into account, well, we've developed a product, but it's the scope 3 emissions, which is the use of that product as well, right?
Yes. Yeah. So yeah, I think that's a good that is definitely similar. One of the challenges lubricant manufacturers that are doing life cycle assessment actually really have no control once it
Mhm.
leaves their property over the use of the product or how it's treated at the end of its life. So it's understandable why there is they spend their focus on cradle to gate analysis. But still, just understanding the carbon footprint from the very beginning to the very end of the product is I think a really important way of trying to assess what actions you can do to then lower your carbon footprint.
Yeah. And a little bit like we talked about with the calculation of energy efficiency benefits, um, is there any kind of standardized way to do these life cycle assessments? I'd heard somewhere that API might be coming out with some kind of standardization this year. Do you know anything about that, or are there any alternative ways to calculate the total carbon assessment?
So a life cycle assessment is governed by there's a couple ISO standards. However, the ISO standards are very general. So, American Petroleum Institute is coming up with a standardization methodology specifically for the lubricant industry.
Mm.
So, I think this is going to be a really important standard to basically standardize a methodology on how everybody is measuring the total carbon footprint and going through their life cycle assessment. So yeah, I'm not sure when that is going to be published, but I've seen some drafts of the document, and I think it's going to be a very very useful, powerful document.
Yeah, it'll be handy. I mean, both from I think it sort of inspires a bit of confidence in the process, right? In that, people on the manufacturing side will have a standardized way that they can do these calculations, which will make it much easier as well. Because at the moment, trying to find all that data is quite difficult. And then from an end user side, you have the confidence that a standardized process was used, to come to that number. So I think, overall, that'll help increase the confidence in the system, which is fantastic. Um, Now, one of the things that you've talked about in the past was this idea of the overall sustainability of a lubricant product being a combination of different factors. So you've got, for example, there's the formulation parts. Is it a synthetic or not? For example, what is it composed of? You have the end of life assessment. So how are we disposing of that product, whether it's re-refining or incineration? the way that it's manufactured, the energy efficiency of the lube oil itself. And one thing that you do carve out, though, is that the toxicity element is kind of a little bit separate, right? Because it doesn't directly affect the carbon assessment of the lubricant, but it does have downstream effects. If we release into the environment, there's kind of that risk profile associated with the lubricant. Now, my question would be, is there a way at the moment to easily or readily make all of that information available to the end user um, in some kind of like standardized labeling form? Because I think the challenge that end users have at the moment is that because there's not that much standardization in these carbon assessments or life cycle assessments, they're getting sold the environmental benefits of products, but it's often comparing apples to oranges to mangoes. So it makes it very difficult for them to make a clearly defined choice about what is going to be better for them. So is there some kind of way that we can convey that information readily as an industry?
That's a great question. And there's no question there's a lot of greenwashing that we see in the industry. But I think that API's initiative to have
Mhm.
a more standardized way of doing LCA, I think is going to be really important. But the next step is, there's still many lubricant manufacturers have not done life cycle assessments of all of their products. Certainly, a lot of additive manufacturers have not either. So we still need a lot of work to be done to properly do these LCAs. But ultimately, I'm not sure if this is going to be publicly available information until end users actually start to ask for this.
Mm.
And when end users are starting then to evaluate different products, and one aspect of it is its overall total carbon footprint. And when they request this on a bid sheet, you can be certain that lubricant manufacturers will first make this information publicly available. And second, I think a little more effort will be put into the actual carbon footprint of the overall carbon footprint of manufacturing a lubricant. So I think this is probably going to be end user driven, but we are seeing more and more end users that are interested in this. There's a nice upside for lubricant manufacturers that are already kind of down this path, because if they are in fact making a product that has a lower carbon footprint, that is with demonstrable energy efficiency improvements, this can actually be a powerful sales tool for them as well.
Yeah. Now, in Australia, for example, we have a sort of a packaging scheme, which kind of relates to the type of work that you're talking about. So, consumers, well, actually, sorry, it's the lubricant companies actually pay a tariff based on production of product. I'm pretty sure they do it on a per liter basis, and that money is set aside that is then put into re-refining schemes as kind of a subsidization exercise. Now, in the way that you're talking, where incineration can potentially eat up the majority of the carbon in a life cycle assessment, so any avoidance of that incineration stage has probably maximum impact from a carbon standpoint. That's an example of government intervening in the market to kind of force that technology in some senses, right? Do you see government anywhere else getting heavily involved to try and make some of those technical decisions?
So I think that not just in Australia, but across the world, a lot of governments have focused on trying to re-refine, especially used motor oils, but
Mm.
set up re-refineries and encourage people to purchase re-refined oils. In the U.S., the government is required to first try to purchase a re-refined lubricant. And if you think of the U.S. government and all branches of military, that actually is a fairly large amount of lubricants that are used. So I think there's a pretty significant role that government can play in trying to encourage the use of re-refining. And you see this there's huge disparities in I think Italy has something like the high 70s of the used oil that's collected is actually re-refined, and the US is more like 32%. And you could see in countries that have put a lot of effort into building a re-refining infrastructure and that have government support end up with a much higher percentage of the used oil being re-refined.
Yeah, thanks for that. That's really interesting to see that how it progresses across the planet, and some of it's cultural, right? How much is the government willing to intervene in markets to drive specific technology decisions? Um, Maybe as we start to round out this interview, I always like to ask a bit of a question about the future, and I think one of the things that would be of interest to the people who listen to this podcast would be, what does it mean for the future of lubricant formulations? Like, how might we see lubricants themselves change as a result of some of these life cycle assessments? So, just off the top of my head, as an example, something like a polyester seems to kind of tick a lot of the boxes when it comes to the different sustainability criteria that you talked about, right? So, life, right? So they get extended life. They can be manufactured from renewable sources, a bit of this and a bit of that, right? They can have some energy efficiency benefits. So that would just be an example off the top of my head, right? But are you seeing any other specific technologies that could be adopted by the lubricant formulations, which would help us in all the different parts of the pie when it comes to sustainability?
Yes. So that's a really good question. I think um, using plant-derived polyesters or plant-derived PEGs absolutely can fit the bill for low carbon, long life lubricants. And I would say a lot of investment right now is being made into plant-based lubricant technologies. And the ultimate goal is that these base oils or these technologies have superior performance compared to their mineral-based counterparts. That really is the ultimate goal. I think one of the challenges we see is that even if you have a carbon negative or carbon neutral oil, if you don't use it in the best application, then you're going to run into some challenges. So, for example, if you're using a PEG in an application where there's potential mineral oil contamination or a polyester or an ester-based fluid that is really susceptible to hydrolysis, and there's a lot of water in that application. Or in some cases, I think that these plant-based formulations have they've gotten a negative a reputation, and in many cases, it's just because they're maybe not used in the ultimate application. So I think that's one of the key factors when you're using any lubricant. You need to make sure it's optimized for that actual application. But long term, I see significantly more growth in these renewable base stocks, certainly compared to mineral oils. We're already seeing that oils are growing at more than twice the rate of mineral oils in the mineral oil market. But I think we're going to continue to see that. But in the short term, mineral oils aren't going to be going away anytime soon. They're going to be with us for a long time. So whatever can be done to try to maximize their life and performance really only has a positive impact on end users' maintenance budgets and also can improve their overall sustainability.
Mm. Yeah, and I guess just on that, I mean, obviously, you guys at Fluitec are doing a lot of work around life extension of lubricants, whether that's through filtration or top treat additives and things like that. Um, so that component of it, there's also some new technologies. AF's got that what's it, double separation technology that I'm not entirely sure how that works, but um, are you seeing any other kind of exciting technologies just around life extension? Because you already talked about the fact that incineration can make up a huge component of the life cycle assessment. So extending the life then becomes extremely important. So, you put those two factors together and it says, okay, life extension of mineral oils, which are going to stick around for a long time, is still going to be an incredibly important component of sustainable lubrication. So is there anything that you're seeing that's really exciting on the horizon?
I think that this is a different question than on engine oils. Engine oils, it really
Mm.
depends on actually the science behind the formulation. If you make a better formulation, the oil could last longer. With industrial lubricants, the two predominant factors on why you have to change an oil is it becomes contaminated, or if you can keep it relatively contaminant free, the sacrificial additive components deplete. So I think it really comes down to dealing with those two components. If you can keep an oil contaminant free, clean, and dry, that's going to do a lot to extend the life of the oil. And then as the oil is used and all sorts of internal contaminants like sludge and varnish are produced, you need to be able to remove these dead additives and degraded hydrocarbon molecules. But then ultimately, if you want to have a big impact on extending the life of the oil, you need to look at replenishing the additive components in in-service lubricants. That is a complex subject, and we certainly don't subscribe to just buying additive off the shelf and dumping it into an in-service oil. But that I think has a lot of benefits and a lot of potential. I think in the coming decades.
Yeah. Hey, great. Greg, thanks so much for sharing your insight. For everyone that hasn't already downloaded, I should say, a copy of Precision Lubrication magazine, there's already been a couple of issues published, and by the time we get around to publishing this interview, it should be approximately on round 3. So I'd encourage you to do that because Greg's articles on sustainable lubrication go even more into depth than I think we've probably gone today. So they're really good reads. Greg's a great writer, so highly encourage you to pick up a copy. Greg, thanks so much for sharing your insight, and I'll have to have you on again soon.
Wonderful, Rafe. I appreciate it. Thanks so much.